So for example number 1, we're going to look at y is equal to negative tangent of 2x. Whoops. Kind of stuck to the thing there. Okay. And then it asks us to think of it in terms of a basic function, locate the asymptotes and all that stuff. So there's a couple things I want you guys to remember. Remember that tangent of theta is really sine of theta over cosine of theta. Okay? And so let's think about that. If I think of the sine of theta over cosine of theta, that's a fraction, right? And what's the one thing we don't want with fractions?
That's zero
What?
on the bottom.
0 in the denominator. Does cosine equal 0 from time to time?
Yes. No.
Yes.
Yes.
Yes, it does. So there are certain points when cosine will equal 0. And what do you think that means for tangent?
No solution.
Undefined.
Undefined is the better term, but yeah, it's undefined. Okay? And so that affects the graph. Now, whenever we've ran into a rational expression being undefined, what do we have graphically? Do you guys remember? Yes, you're making the right hand gesture. What do we have?
I was scratching my eye.
You were scratching your eye? I thought vertical asymptote. Do you guys remember that?
Parabola. Is that what I was doing?
No, go back to scratching your eye.
Scratch your eyes.
I went.
So what we have is a parabola. No, we don't have a parabola. What we have is a vertical asymptote that occurs when this equals 0. So let me show you what I mean by that. If I clear this out, and I gotta go to a standard window.
6. Oh, 6.
Actually, I'm gonna do trig, so I'm gonna do 7. And if I go to, and I want to graph cosine of x, that's going to be the blue function, okay? We see at certain points cosine is equal to 0. In other words, what I mean is like right here, the y value of cosine, let me put that in a different color so you can see that. Right here, we have cosine equaling 0, okay? And so whenever the denominator equals 0,
It's a really bad line.
I know, that's all right.
It's not.
We're going to have a vertical asymptote.
Oh my gosh. Oh.
I like the noise.
No.
Now, what will sine over cosine look like when we graph it? In other words, what will tangent look like when we graph it? Well, it will look like this.
Whoa. Oh, amazing. Amazing.
Okay? So that's the first thing I want to talk to you guys about tangent. Now, this is just regular tangent. What were we asked to graph?
Negative
tangent 2x. So what I'm going to do is I'm going to come back and I'm going to graph negative tangent, and that will be in red. So we're going to do negative tangent. Now, before I hit enter, what is that negative sign in the front going to do?
Flip it.
Flip it about the x-axis. So let's see if we're correct.
Is it? It was 2x.
I know, we're getting there. I'm transforming it one thing at a time.
That is.
Parabola.
They're X chromosomes.
So the red line is just the blue line flipped over the x-axis, isn't it?
Yes.
All right, so now let's go back. And I'm going to turn this off for now. And then the next step would be is I'm going to have negative tangent of 2x. Now I want you guys to think about this for just a second. What is that 2 in front of the x going to do?
Shrink or stretch.
Shrink, yeah, so the term in front of the x is either going to shrink or stretch horizontally. Now let's think about this. 2 is greater than 1, So if I were to plug in 90 degrees here, what would I really be evaluating tangent at? If x equals 90? 180. So think about how that affects the graph. Would that stretch it or would it shrink it?
Shrink. Stretch.
Raise your hand. We're going to find out. How many people think shrink? All right. How many people think stretch? All right. We're going to find out. You guys ready? Let's see.
Yas.
Ha 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 ha.
So there's the original negative tangent of x. What did it do?
Definitely stretched.
Cool, I just copied what you said.
Shrink.
Yeah, it compressed it. No, we have way more. We have way more black curves than we do the red curves. So it compressed it.
It's just
I thought
stretching
you
this
meant
way.
like it's
Oh.
this way.
You could think of it that way, but normally we don't associate it with that term. We associate that with the amplitude, with the A term, the one in front, right? Okay? Does that make sense? All right, so that's basically, now what they want us to do is think of that in terms of basic functions. So the effect of the two is a horizontal shrink on the graph by a factor of 1/2, and the effect of the -1 reflects it across the x-axis. That's pretty much it. The period of the original function tangent is actually pi as opposed to 2 pi. So let's just write some notes down. Are you guys writing this down?
Yeah.
So let's write down what the original tangent of x looks like with regards to some terms. What was the domain of that thing?
All real numbers.
All real numbers. So the domain was all real numbers. What was the range?
Like every
Oh wait, let's think this through. It was all real numbers, sort of. So I'm going to come back here. Let's turn tangent back on. We'll turn the other ones off. And let's look at this. Is x really all real numbers?
No.
No, we have those vertical asymptotes. When do those vertical asymptotes?
even numbers. Starting with even numbers like 2.0.
Well, they occur here, right? So they occur here. So what is that value?
0.
Well, yeah, it's when cosine equals 0. When does cosine equal 0?
Even numbers.
Well, let's think this through, okay? On the unit circle, a perfectly drawn unit circle, remember that it's cosine, comma, sine. We always think in terms of x and y, but on the unit circle, it's cosine, sine. So this point right here on the unit circle is 1, 0. This one here is 0, 1. This one here is -1, 0. And then this one here is 0, -1. And what we're looking for is when cosine, the first term, is equal to 0. So that occurs here, right? And that occurs here. So now what angles does that occur at?
90 and
It starts at 90 or pi over 2. And then over here we've got 3 pi over 2. And what is this angle here? This is 270, right?
Or -90.
Yeah, or -90. I'm actually glad that you said that. He said or -90. In other words, if I rotate around this way, that would be -90 degrees or -pi over 2. And then this one up here would be -270 and -3 pi over 2. What's the difference between, like, how far do I rotate to get from here to here? 180 degrees. What is that in radians, though? Pi. And then because this is a circular function, how far do I go to get to the next 0?
2 pi.
360.
No, starting from here though.
180.
180. So how often does this 0 occur? Every pi or every 180 degrees. So I guess when we look at this graph, that vertical asymptote occurs at pi over 2 first. And then we have another one exactly pi over. Does that make sense? So this would be pi over 2. This would be 3 pi over 2. If you were to guess, what do you think this is?
6 pi.
No.
Pi.
We're adding pi, which is the same as 2 pi over 2, so that would be 5 pi over 2. And then Cole figured out, before I could say it, that you do the same thing, but now with negative numbers. So this is negative pi over 2, negative 3 pi over 2, negative 5 pi over 2. So that's where you have these vertical asymptotes. So when we come back here, we're going to say all reals except, and I'm gonna word it like this: k times pi over 2. K is odd integer. Does that make sense? Because you've got 1, 3, 5, 7. What is the range for this though? For tangent? The range for tangent is all reals. And then lastly, what is the normal period? How often does that cycle repeat? When does the cycle repeat?
After 180.
180 or
Pi.
pi. So we would say that the period of this thing is pi. What's the period of sine and cosine?
Isn't it?
2 pi. 2 pi. But because we're taking sine and dividing it by cosine, we end up with this behavior that repeats itself every pi. So the period will be pi. Okay?
Yes.
Any questions on that?
No.
Okay, that's all I have for example number 1. Where are we at on time?
Not time for that.
10 minutes.
No time.
Totes.
We've had so much learning today.